that in a bank you deposit $100 each month. For example, this is a bank, and every month you deposit $100. That is in January. And you continue deposit the same amount every month. For example, in February, you deposited the total amount is $100 from January, then $100 that you saved for February, and the total amount is $200. And if you continue with that, the question is asked how much money you deposited in until next January. So it means that in January, how can we answer that? In January, you saved $100. Then in February, you deposited again $100 and it becomes $200. Then you have $300 and so on. So we need a formula to find out the final amount, or maybe at final year, where you want to see how much money is saved. Here you have learned that we have a sequence. This is called sequence. So here we have a sequence. The definition of sequence, which says that you deposited some money, then $200, then $300, and continue with it. Now imagine that the bank gives you $10 bonus each month. So you start with $100. Bank gives you bonus for $10. You get 110 plus 100. So you have $210. Then in the next month, you have, for example, 320, and we continue with it until we like. So this is another example of a sequence. Now look at the third example of sequence. Suppose every month you save $100. Then every next month you double it. Maybe you are doing some business or something like that. Then we have 200. Then we have 400 and 800, so on. This is another example of a sequence. So what we do in mathematics, or maybe we are studying this in discrete mathematics, we can call that A1, we call that A2, this is A3, this is A4, so on, and we add comma into that. So this becomes a sequence. So the sequence becomes A1. Sometime it happens that you start the index with A0. It is also fine. You can also write A0, A1, A2, so on. Then you can write, for example, A1, A2, A3, so on. So this is sequence written generally. These are the motivational example. But in mathematics, we try to understand every sequence we encounter, even mathematical or maybe has some applications. So the notation, how can, every time we cannot write the sequence like this, we have to show this in a compact form, and the compact form of above sequence is an in curly braces. Whenever you see such notation, then this is an example of a sequence. The sequences, different sequences, for example, if you have another sequence of Bn, then you can also write in curly braces. How the sequence is defined formally? The sequence is something that takes input from either from 0, 1, 2 or from 1, 2, 3, so on. And the output is an, an. Okay, an is called the nth term of the sequence. I hope you got the notational idea and some background. Now we want to see some examples on sequences. The first example we see over here is a sequence of an is equal to 1 over n. An is equal to 1 over n. So the list of numbers are, if you start n with 1, a1, a2, a3, so on. So a1 is 1, a2 is 1 by 2, a3 is 1 by 3, so on. So this is the sequence, and actually the sequence was written as like this, an 1 over n. So remember that the formula for the sequence gives the nth term of the sequence. It can be first term, it can be second term, so on. Now look at another example. There is one particular example on sequence, and that sequence is geometric progression. Geometric progression. Geometric progression is a, ar, ar square, so on. And at the end, nth term is arn. Such sequence is called geometric progression, since it can happen that the next term can be obtained from the previous one by multiplying this with some common ratio, which is r. Suppose you can obtain 2, for example, the first term is 2, you multiply this with 2, you get 4, then you multiply with 2, you get 8, so on. Okay. This geometric progression can have a similarity in calculus, and we call that function. For example, this can be written as a r, and then we have x. For example, we have f of 1, this is a, And also ratio is, for example, r is maybe x0, for example. First f of 0, then ar0, we get ar, then f of 2, we have ar square, so on. So this function, this geometric progression, which is a sequence, can correspond to some function a r x. Now we look at another example, maybe the last one, arithmetic progression. There is another sequence, some particular kind of sequence, arithmetic progression. This is also very interesting. Sometimes it happens that you get the next point by adding some particular number into that. So such sequence is called arithmetic progression. For example, a plus 2d, then a plus 3d, so on. Such sequence is called arithmetic progression. And if you want to draw a correspondence between this sequence and the function we study in calculus, we can write this as f of x is equal to dx plus a. Maybe I write this formally, f of x is equal to a plus dx. So this is the sequence that corresponds to this function, and this is called arithmetic progression. Thank you for watching.